Have you ever looked up at the night sky and wondered what's up there besides the stars? Well, today we're talking about satellites, our eyes in the sky. These things are basically the silent workhorses that connect us, guide us, and show us our planet in ways we probably never even imagined.
All right, so here's what we've got on the docket. First off, what even is a satellite? Then we'll get into what they actually do for us, their different jobs. We'll talk about their orbits, the paths they take through space. And we've got a special feature on the geostationary superstars. And to wrap it all up, we'll look at why satellites matter so much in the first place. Okay, let's get right into it. What is a satellite? Now, when you hear that word, you probably picture some high-tech machine whizzing around in space, right? And you're not wrong, but the idea is actually way older. To get our heads around it, let's start with a little question. Just, mull this over for a second. On one hand, you have the moon, this huge natural thing that's been inspiring people forever. On the other hand, you've got the GPS in your phone that helps you find, the closest pizza place. What in the world could they have in common? Well, believe it or not, they're both satellites. And that right there really breaks it down into the two main types. You've got your natural satellites, like the moon, basically any big celestial body that gets caught in a planet's gravity. And then you've got artificial satellites. These are the ones we build and launch ourselves for all sorts of jobs, like, you guessed it, powering that GPS so you don't end up on the wrong side of town. So that brings up a good point. We don't just fling these billion-dollar machines into space for the heck of it, right? Every single one has a very specific job to do. And probably the easiest way to classify them is to just look at their purpose, what they were built for. Okay, first up, let's talk about communication satellites. This is probably the one you're most familiar with, even if you don't realize it. I mean, these things are literally the backbone of our superconnected world. Think of them as giant relay stations just hanging out in the sky. Yeah, I love this analogy. They're like space mirrors. It's a perfect way to think about it. They catch a signal, whether it's for TV, your internet, or a phone call, from one side of the planet and just bounce it right back down to the other side. That's exactly how you can watch a live event in Tokyo instantly on your screen in New York. And you've probably heard of some of these names. You've got the old school players like Intelsat handling big international TV broadcasts, and then you have the new kids on the block like Starlink, which is this huge constellation of satellites trying to bring internet to everyone. The goal is always the same though. Keep us connected no matter where we are. All right, next up, navigation satellites. These are the ones that tell you exactly where you are. And I'm not exaggerating when I say that without them, our entire modern world of transportation and shipping would just stop. So here's the cool part. It's not just one satellite. It's a whole group, or a constellation, working together. They're all constantly beaming down super precise time signals. Your phone is smart enough to listen for signals from at least 4 of them at once, and by doing some really quick math on the tiny differences in when those signals arrive, it can pinpoint your exact location on the globe. It's pretty incredible. And it's funny, we all just call it GPS, but that's actually just the American system. Other countries have their own versions. Russia has GLONASS, Europe has Galileo, China has Beidou. It's because this tech is so critical, they all want their own. But the best part is, your smartphone doesn't care. It uses signals from all of them to figure out exactly where you are with amazing accuracy. And that brings us to our last major category. And this one's a biggie: Earth observation and research satellites. These are literally our eyes in the sky, looking down on our planet and also peering way, way out into the universe. Their whole job is about gathering knowledge. They're the ones tracking hurricanes, watching the ice caps melt, mapping out where forests are being cut down. They even provide the data for the weather app on your phone. And then you have the really famous ones, like Hubble and the James Webb Space Telescope. They're pointed the other way, looking deep into space and giving us these absolutely mind-blowing pictures of the universe. Okay, so we've covered what satellites do, but what about where they do it? You see, a satellite's orbit, its path around the Earth, is totally connected to its job. And the easiest way to start thinking about orbits is just by how high up they are. So you can basically think of it in 3 main zones. First, there's low Earth orbit, or LEO. This place is getting pretty crowded. It's where you find things like the International Space Station and those Starlink satellites. And they have to move super fast to keep from just falling back to Earth. Go a bit higher and you're in medium Earth orbit, or MEO. This is kind of the sweet spot for navigation systems like GPS. Then way, way out there, you have high Earth orbit, or HEO. Up here, things move a lot slower. In fact, some satellites take a full day to go around the Earth just once.
And that high Earth orbit we just talked about, well, there's a specific spot up there that has this really special, almost magical quality. If you get a satellite to exactly the right altitude, something amazing happens. And it's something we use for some of our most important tech. It's a great question, right? How can a satellite, which is just screaming through space at thousands of miles an hour, look like it's perfectly still in the sky? From down here on the ground, it seems impossible. While the magic is all in the physics, it comes down to 3 super specific rules. First, the altitude has to be exactly 35,786 kilometers, and it has to be right over the equator. Second, its orbit has to take exactly 24 hours to complete. And third, it has to be moving eastward, the same direction the Earth is spinning. You nail all 3 of those, and the satellite perfectly matches the Earth's rotation. It's kind of like 2 cars on a highway going the exact same speed in the same lane. From one car, the other looks like it's not moving at all. And having a satellite that stands still is a total game changer. Think about it. For satellite TV, you can point your dish at that one spot in the sky and just lock it in. You never have to move it. Or for weather, a geostationary satellite can just stare at the same part of the world 24/7, watching a storm develop and move in real time. That constant, uninterrupted view is absolutely crucial. All right, so this brings us to the big picture. We've talked about what satellites are, what they do, and where they hang out. So let's wrap this all up and really look at the incredible impact these things have had on, well, everything. Seriously, it's no exaggeration to say they started a revolution. Global communication that links up the most remote places on Earth, that's satellites. The navigation that gets massive cargo ships across the ocean, satellites. Those early warnings for hurricanes and other disasters, you guessed it. They are just completely woven into the fabric of modern life. To put it simply, our world today just would not work without them. They're like the invisible infrastructure that powers so much of what we just assume will always be there, every single day.
And this really sums up the whole geostationary thing perfectly. Their ability to just hover over one spot makes them the undisputed champions for anything that needs a constant, reliable connection. There are fixed sentinels in the sky, the bedrock for so much of our global infrastructure. Think about it. In just a few decades, we went from launching simple beeping spheres to putting these incredibly complex robotic telescopes into orbit. Satellites have completely changed how we see our own planet and even our place in the cosmos. So that leaves us with one last question to chew on. These machines have already changed our world. What will the next generation of satellites see?